happy to introduce Miro, who is one of the committers in CSIT. And really the session is about CSIT project and testing. But I wanted to quickly refer to, for those of you who were here on Tuesday during my presentation, that the testing here is not only a matter of testing a product or a system that is supposed to be shipped and be commercial, but it's also to be part of the development process. So we are working, our mantra is really to provide an immediate feedback loop to the guys who are writing the code on whether the code is doing what is expected to do from the functionality perspective, whether it breaks anything in terms of collateral, and also clearly empower the community to provide them with the tools and feedback specifically for performance testing that are otherwise not available. And Miro will cover quite a lot of that in detail, but it's about functionality and performance testing from the integration perspective. And really what we are after here, and we didn't really have this opportunity before in the DevBoot 1 in San Jose, is to give you a more detailed walk through the code and the system. Miro actually coded a MaxSwap example, which is accompanying the sample plugin that the VPP dataplane guys did by swapping the Mac. And I think that's what we're going to walk through the code. But we're also after feedback. So hopefully we'll have time at the end of the session to get the feedback from you on what you like, what you dislike, and what you would like to see ideally from the system that gives you basically tests your code. So we are very much after feedback, and feedback comes without strings attached. Well, I'll talk about the strings later.
The agenda is we will cover the CSIT background environment, which you can find the how-tos for Windows and for Mac on the FD.io wiki, how to set up the 3-node topology and how to bring up the CSIT environment, how to install VPP, how to do that. Then what's the directory structure of the CSIT project, where you can find libraries, topology files, and so on. What are those topology files, how we can use them, where can they be used in the tests, and then some basic steps, how to do tests. RobotFramework, we are using RobotFramework as a top-level driver of the tests, so some basic concept from RobotFramework, and then some example of the MaxSwap based on the MaxSwap example in the VPP and the same plugin. So if you go to this page and you follow the tutorial how to bring up your vagrant environment, you will get a 3-node topology which contains the device under test, 2 nodes of the DUTs, DUT1 and DUT2, and then the TG, which is traffic generator node, pumping the traffic to the DUTs. Then the Windows setup, which is on the wiki, contains a development VM, where you can basically connect the network, which is here. You will get a separate links between the devices, and then there are 2 networks. One is the management plane, the host-only network, that the development VM connects to the DUTs, setting up basically everything, restarting VPP, grabbing the statistics, setting up the traffic generator, executing scripts, grabbing back the results, and then the internet access for getting the libraries from pip install, I guess. You will get this 3-node covered. What the Vagrant app does not cover is your development VM, so you can just choose to which network connects it, so that you can control the environment. This link contains anybody here who tried that Vagrant tutorial, which is on the wiki?
Apart from me?
Apart from Maciek. So if you want to try it, please try it and then shout on the CSIT.io, because there are a few steps that I think are not covered very well at the moment.
Well, in Mac.
In Mac.
Just fixed it.
Yep. and for the Windows, it should be working, I guess. If not, then please shout as soon as possible. I had some troubles with the VirtualBox on my environment. I had to reinstall it twice, and it's a bit not straightforward, but it should work well in most cases. So if you download the CSIT codebase, you will get these directory structures, docs, that's self-explanatory. Environment, it's not there. If you download it from the Gerrit, you can create your virtual environment by using virtual env, who is Python code, and you know that. Resources, this directory contains basically all the resources from libraries to templates, drivers, scripts, and then the tests. There you can find the robot files. The robot files are using the resources, which are the libraries and the templates. And then the topologies, where you can find the YAML files defining how the topology looks like. So the tests are using the topology files to basically get the information about the topology and read how are the nodes connected. The resources then contains, who don't see it, there are libraries, which are the low-level libraries written mostly in Python, and the robot libraries are just wrappers of multiple commands. So if you write a new test and you are using it in some keyword in multiple tests, and you don't want boilerplate, so this is the best place where you should put your function if you want to use it frequently. And the bash, I don't know what is the bash. There is one script that is doing the BPP restart on the node, from what I remember. Templates. Currently, two directories, honeycomb and VP API test. What? There are the files used for configuring the VPP instances. So for example, bringing up the interface, if there is a call which is brings up the interface, then there is a curly bracket where the code before it executes it on a VPP node. It just fills the necessary information before it pushes to the VP API test. So those are the templates, and then the tooling is everything else, from like installation of the T-Rex, the grabbing the topology, grabbing the information from the nodes, filling up the PCI addresses of the topology files, vagrant files. So basically, this is the vagrant directory where you can find the vagrant definition file. If you run vagrant up, it will read the vagrant definition from the directory. And then viral, those are all the scripts that are driving the viral environment, which we are using for the functional testing. Topology schemas contains schemas for validation of the topology files. So if you write a topology file like 3-node topology, you can use that schemas to validate if the topology file doesn't contain any errors or typos. Traffic scripts. The last directory in the resources directory contains the scripts which are executed on the TG node to send and receive and check the packets on the data path between the nodes. Tests directory. There is around 10-11 suites. All of them except one, the performance suite, are functional, and each of the directory contains test definition. For instance, the bridge domain contain. All this is pretty much self-explanatory. Lisp is a suite that tests the Lisp functionality of the VBP. The test suite, to be able to configure the environment, it needs to know how does the topology looks like. In the LF infrastructure, we are using mostly the 3-node topology with 2 DUTs and 1 traffic generator. And the topology file describes how the topology looks like. So I took as example a 3-node topology with a single link between the nodes. I hope there is a example from the repository.
Sorry, Miro, can you go back to the previous slide?
Yeah, sure.
So I don't know whether you got it from the earlier slides and also from my talk on Tuesday. For functional tests, we're using SCAPI to generate and receive packets. For performance tests, we're using T-Rex, which is the open source traffic generator. So there is a slight difference in the setups between the functional tests and the performance tests. And we're looking for any help we can get on getting the performance tests hardened from, including drivers for other traffic generators like Ixia or Mugen. So if you are interested to help with that, we'll be very interested too. Thanks.
Well, there is a Jenkins node which drives the tests. I will cover that in a moment, how the test workflow looks like. Topology files. This is a 3-node topology. Yep. So we have a metadata belonging what schemas to use if you verify that YAML file, and then there are nodes. In this case, there is a traffic generator DUT1 and DUT2. You can use any keys you want. And the section TG, I just put it on the separate slide because it's a bit unreadable. So the TG section contain basically every node contains its type. If it is a TG, then it's traffic generator, and then it can be a subtype. So currently we are using T-Rex, but if we add some lightweight traffic generator or something like that, we can change the subtype to or Ixia parent or whatever it can be in the future. Then the host port, so that the test framework will know where to connect, on what port to use, username, password if we need it to connect to that node, and then list of interfaces containing the MAC address, PCI address, and the link. That's the important one because the link identifies the link to the second node. So this is a unique identifier of the link. So if we take a look on the first port, which is port 3, then on the DUT1, we'll see that the link 1 is on the port 1 connected to the DUT1. Again, this looks similar to the traffic generator. The only difference is that this type is DUT and we don't have a subtype because currently we only have BPP on the DUTs. Port 22 currently we are using SSH to control spin up and basically grabbing the information from both TG and the DUTs. This topology file is read at the beginning of the suite setup, and it is translated into a Python dictionary. And there is a library that allows you to define the path in the topology. So you will you just can add a node, then add another node, add another node, and then you just type compute path, and it will compute path based on available links that are read from the topology file. And you can work with those interfaces you can store them as variables. You can then use them for the configuration of the nodes and sending the traffic and waiting on the other side for the send traffic. I think that's it from the topology files. Workflow, it's pretty simple. You just set up some basic variables, then you configure VPP, run the test, and then you report the status. That's it. It's not a rocket science. The first step is that you read the topology file, you create a dictionary from that, then you copy your local workspace and you copy it to all the nodes. So you can use the same code from the workspace, not only on your development VM or Jenkins in a LF infrastructure, but you can use also the same code on all the nodes. On the TG, there is created also the virtual environment, I guess. And then the feedback, which is the third step, is that you grab the informations from the VPP about what's the, not only VPP, but also from the traffic generator, what's the name of the interface, because the topology file contains only the PCI address, and the name of the interface can change in time if you reboot the server or whatever, you change the UDEL configuration, or you change the number of interfaces VPP is using, then the internal indexing of the interfaces can change. So there is a feedback in the third step that you connect to all the nodes. You grab the interface names, you grab the internal IDs from the VPP, and you store it into that topology dictionary, where you can use it later for bringing up the interfaces, showing stats, and configuration, and getting the telemetry from the environment. What you want to know probably is the compute path. So you select the nodes which you can use, which you want to use. If you have multiple links between the DUTs, you can use, there is some basic filtering based on the NIC type. You can select, I want to use 10 gig interfaces between DUT1, DUT2. The compute path, there is a function which computes the path between the nodes, and then you set up your variables if you need them. If you don't need them, you can have it in an instance of any class you used in the test or a test suite. You can have a test suite scope, or by default it is every instance has a scope within the test that is running, but you can change the scope to the whole test suite. So first, if you initialize some variables that you want to use in all the tests, then you can change the scope of the instance, and you can use it in all the tests within that suite. And the fifth step is the setup of the DUTs. If you want to test IPv4, then you need to configure the routes or setting ARPs or whatever bridges. And after you set the environment, you can ask the TG node to run the traffic. And then you just retrieve the feedback from, if it is functional testing, then you retrieve feedback if the specific test was successful, that, I don't know, TTL was decreased, the VXLAN packet or ping or whatever passed through the topology, and the process executed on the TG received the packet back. Or in the performance testing, we capture the statistics, how many packets has been lost, what was the PPS, what was the CPU utilization, and currently we are adding the latency. We'll see how it goes. And then the Jenkins framework just capture those stats and use them later for reporting how the tests were executed, where it failed, where it doesn't failed, how many packets did we lost, whatever. So that's it from the test workflow. If I go back, the control plane testing is pretty much the same as this is the data plane testing, and the control plane will be is pretty much similar as the setup DUTs, but you need to get a feedback from the DUTs if the interface is I don't know, if you bring up the interface, then you just look at the CLI, or you just call an API and you see if the interface is up, or if you add 5 million routes, then you need to take a look to the DUT and get a feedback whether the routes has been actually added on the node. We are using RobotFramework because it provides the basic infrastructure to execute the tests and then report them, and it is easily integrated into the Jenkins, so you can take a look how many test cases are successful, how many failed, and then it provides a feedback back also to the Gerrit. So for every proposed patch in the VPP, there is a run of CSIT functional tests. It runs all the functional tests in viral environment, and if every tests that are expected to be successful are successful, it +1 on the Gerrit. If not, then it just put a -1 on the patch. So you'll basically quickly know if you break something in the functional testing or not. There is a manual trigger for the performance testing as well. Currently nobody is using it. Please start using it. Now, test suite is basically a set of test cases. It can be 1 or 0 or more test cases. And test case is all the test suite is just a scope. So you can have each test suite has a setup at the beginning, then you can execute multiple tests, and then at the end you can run a suite teardown where you clean all the log files, or just grab the core dump files or whatever you want during the test suite scope. And then each test case has its own scope where it has also the setup at the beginning, then execution of keywords, and then at the end there is a test case teardown where you can grab the statistics or restart or put the basic configuration on to VPP, or some cleanup that you want to do. And the set of keywords means that keyword can be either set of keywords or a lowest level library keyword, which is basically a function that you execute to achieve something. So all the functions are currently written in Python. You will find them in the resources / libraries / Python. And I will show that in a moment. In the MaxSwap example, what I already did, I started the Vagrant environment, so I got 3 nodes up and running. I put there the VPP latest from Nexus. I compiled the MaxSwap plugin and installed it on the DUT1. And I'm going to run a RobotFramework library, PyBot, to log all the traces, use variable environment variable topology path, which defines the topology file. You can take a look on this one. It contains the topology. So this is the 3-node topology with the DUT1 available on the 192 blah blah IP address. There is no password. Oh, there is. So the password and username is CSIT. This PCI addresses and the MAC addresses. There is a tool that can help you to fill that in. If you walk over the tutorial on the wiki, you will find where the tool is, and then the DUT2 available at this IP, again CSIT with the different interfaces, and the links are there is a link 1 from DUT1 to the traffic gen, and then link 3 is to the DUT2, and link 2 is connected back to the traffic generator, which is this one. So this is the topology file describing the current topology, and I have my environment, the development VM, connected to the host-only VirtualBox network, and I'm using the network to connect the nodes and execute the tests. That was the topology path, and then the last argument is the directory where are the tests located. So what are we doing now is that we are packing the current directory and then copying to all the DUTs, extracting the environment to TMP open BPP testing on all 3 nodes in parallel, installing virtual env on the TG node, and after this initial setup, we execute a max swap script on the TG node, and we see that it passed, and we can take a look. There is an output XML, which is raw log of everything. You can use it for further post-processing, or there is a human readable thing called log HTML, where, okay, how to read it. Each test case has some RobotFramework tags. Tag define. Currently, we are using tags for defining what topology the tests need to be run on, what environment, what NICs. Then you can use the tags if you expect the test to be failing because you know that the feature isn't there yet. Then you just put the tag to expect failing, and the RobotFramework won't report a failure. Well, it will report a failure, but it will mark the test as non-critical, and then it won't vote on the Garrett -1 if you expect the test to be failing because of whatever reason, like the feature is not there, or you know that there is a problem with the infrastructure or something like that. So just maybe back to the sample test directory. It contains a single file, sample suite, and I will walk over it in a moment. First, let's take a look on the reports. So the suite is called sample tests, and then you can put a two underscores in it into your suites if you want to do any initialization at the beginning of the sample suite, or you can define setup within the RobotFramework dash robot file. At the beginning, there is a setup doing so this is the setup phase, and it is executing the setup framework nodes and set up all DUTs and set up all traffic generators before traffic script, and update all the interfaces data on all nodes, and set up nodes for max swap testing. So this is the initialization phase of the suite. And if you click on that, you will see each step executing the keywords. If you are using the trace level, it is pretty much a lot of information, and you can find that we packed on the whole directory. We used this is the topology file parsed as a dictionary. The workspace has been packed, and then we should copy it to all the nodes, which is set up all DUTs. Keyword is capturing the setup framework, copying the environment. It executed the DUT setup that brings us a basic information about the environment, the VPP version, if the VPP is running or not. Then the startup configuration. This is just information. How does the environment look before we execute any tests? Memory information. This is useful, especially if you want to see how many huge pages has been allocated, how many has been used. Then the devices, PCI devices, and so on for all the DUTs. And then set up all traffic generators, which will bring up well, first, if we are using T-Rex on the traffic generator, it will bind the PCI device to the IGBUIO driver. So the functional test first just try to bind it to the default driver, this kernel one, so that the framework will be able to use the socket to bind on that interface driven by Linux kernel. And then update all interfaces, interface data on all nodes is the feedback from the nodes, where we connect to all the nodes. We grab the information of each interface and we try to correlate it with the topology dictionary that we parsed before, and we are filling in the interface name and the software, the index of each interface, because we are using that later in setting up basically everything when calling the VPA API test. So that's the feedback from the VPP and the traffic generator. And then set up the nodes for max swap testing. That's the part that is specific for the max swap example. We use the notepad library to first append the nodes. So in this case, I use two nodes. One is the traffic generator, and the second one is the DUT1. And then I call the compute path, and the compute path will figure out that there is a single link between the TG and the DUT1, and I store that computed path. I grab the first interface and store it as a TG port, and then I store the last interface to a DUT port variable, so I can use it later. And then I say just this is a RobotFramework that please make this variable suite variable. If you want to use it for in all test cases, then this is the way how you can globalize your variable. We bring up the interfaces. So set interface. This is TG node and TG port. Bring up interface on the traffic generator up. Bring up interface on the device under the test up. and then we wait for VPP to report that interface that it is really up. That is the admin state, from what I remember. And the actual test is, again, setup of the test, where we clear all the counters on the DUTs. Then this keyword enable disable max swap, what executes the exec sample max swap on the gigabit Ethernet 090. I had to use this exec because the VP API test did not work. I didn't get any return values, so it's the reason why I'm using the CLI, not the binary API. I don't know the reason. Anybody here know the reason why I don't get a return value when I use the VP API test for the plugin?
Who did the sample? You, Ole?
No, I didn't write the sample, but we looked at it previously. I think it didn't actually set the return value in the message going back. We can fix that.
Do we need to open the Jira ticket for that, or can you do it now? Joking.
And then, yeah, so this is the setup. So we enable the max swap on the specific interface, and then the execution is just, this is the IP source destination that we use for that packet that we sent to the VPP. Again, variable source destination MAC, and then we execute the traffic gen. No, sorry, these are, we generate arguments for a traffic script running on the traffic generator, and then we execute the max swap underscore checked by on the traffic generator node with the arguments that we generate in the previous example. The output here is that we send a packet out of ETH2 where the destination address is 0102 and the source is 01, and then received packet. There are actually two of them because it is the same interface. So if you are listening on the ETH2 interface, you will capture both the outgoing and the incoming packets. So I'm filtering that outgoing packet. I will show that in a moment. And then we compare. There is a function that is doing that. This comparing the destination MAC address of the outgoing packet with the source address of the incoming, and then the source address of the outgoing packet with the destination address of the incoming packet. And if everything goes well, then it won't fail. If the MAC addresses don't match, then we just raise an exception in the TG node, which then flows to the RobotFramework, and we will see here as a test failure. And at the very end, there is a show packet trace on all DUTs. This is executed for every functional test. So if you see a failure in the functional test, you can take a look if there was any packets. So this is the output from the show trace, where we can see that the incoming packet was from 01 to 02, and then the MAC address has been swapped to 02 to 01. If the test would fail, you can take a look or it can help you to debug your issue.
Yeah, just a small question. If I understood well, so PyBot or the whole CSIT framework does not start VMs. You have to start them manually, separately, before running tests?
Currently, the tests that are implemented in the functional testing are starting the VMs. There's a keyword for that, like please start the virtual machine before I start configuring the virtual machine or something like that.
Okay, because I tried to run just IPv4 test and it says fail, 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 and so it seems like it doesn't start the VMs if they are not started.
You need to have the VPP to be installed on the nodes.
Okay, so you have to install VPP manually before running the tests.
The test suite expect the VPP to be installed on the DUTs.
Okay.
In the tests that are running in the left, that is done automatically, yes?
Well, there is a Bootstrap script that is doing that.
Right.
The question was why we cannot include in the installation of the VPP included as a keyword or some step during the setup. Yes, you can do that, but you would need to introduce another variable because you don't want to always test the same VPP version. So you would need to have some directory or something where you store the VPP instances, and then you would need to tell, please use these VPP instances, and please don't reinstall the VPP if I'm debugging some code on the DUT locally. So we just expect the VPP to be installed on the DUT, and then there is a Bootstrap script in Jenkins, which Jenkins is executing, and that one copy the proper version of the VPP, which we want to use for testing.
And remember, those tests, the functional tests, are executed per patch. So I think that was one of the drivers.
There is a script called install VPP something in the tooling, where you can just define all the VPP packages and it should install it on the DUTs. Well, if you follow the instructions that are on the wiki how to bring this environment, there is a one step. Please install the VPP that I downloaded in the previous step on all the DUT nodes.
May I ask a high-level question?
Yep, sure.
So that's a gating CI, right? It's before to be pushed that you run the test, or it's post-push?
It's before to be pushed to the master. So for every proposed patch, you need to run a set of tests to build the VPP. Or well, there are two projects, VPP and CSIT. We are running for every proposed patch in the VPP and as well in the CSIT. Not only, well, VPP is running not only the CSIT suite, but it's also running if the VPP builds. And there is one more step. I don't remember what that was. And for CSIT, we are running for every proposed patch the pilot validation, and then we are running the whole functional test suite against the latest stable VPP.
Okay, so that's a gating CI, right?
Yes, the code is tested before it's even reviewed.
So, and I've looked at the wiki and the test plans. So you can somehow understand what's going on, but do you have tests with VM running on top of VPP? Functional test and
VM running on top of VPP?
Yes, when you use VPP as a vSwitch, do you have test, a performance test? And I'm not sure when I read your test report.
There is a functional test that is doing that, but running VPP and the VM on the same node.
Testing VPP as switching between the physical interfaces and the VM interfaces, vHost user interfaces.
Yes, exactly.
So functional tests are there. I think it's L2 cross connect. There is L2 bridge domain. I don't think we have IPv4, IPv6 forwarding yet for functional tests. For performance tests, I think this is in the pipeline.
It's in the pipeline.
The libraries are written, but the tests.
Well, we currently looking for a store where to store the VMs because viral. We can store the VM images inside the viral, but the hardware test bed, it's in the pipeline currently.
So remember, all those tests are executed in LF, and they are operated. The infrastructure, IT infrastructure, is operated by LF, by Linux Foundation. So it's it's not always our choices that we have to also use what we are what's supported. And that's one. Sometimes there is some delay due to that, but so far all the issues we raised got resolved and addressed.
Mm-hmm. Currently, the performance testing is using the bare metal 3-node topology, and the functional testing are using the viral environment. And if they, well, the functional guys, if they run the VM, they have to use the nested virtualization for running VM in a VM.
Do you have some kind of hooks that would allow, let's say, to run some extension of CSIT or some tests, but in a distributed manner? So instead of having everything in the lab, some Linux foundations, to have things on Cisco, Sixwin, or whoever's lab, because we have some systems, some servers that are not easily, let's say, to install in the Linux Foundation labs. I mean, is there any ways, like we do, for instance, with OpenStack, we can plug into the test frameworks? Can we define the same logic with Jenkins, or maybe more Jenkins stuff and to CSIT?
Well, it's the command I run few minutes
but
before.
What if, let's say, I had a new protocol XYZ in VNet, the new node, I push it, I develop a test, and know it needs a specific hardware. I only have it in my company. But every time someone contributes to VPP, I want to be sure that the test get pushed to my nodes.
We can open a discussion. The RobotFramework, you can do something like exclude tests. So we can introduce a tag in the tests library where you just say it is not supported by the LF environment. You can contribute the code into the test framework. The tests will be excluded from the run within the LF infrastructure run, but you can run it locally on your...
Yeah, but I want my test to still to be a voting test when someone sends a patch. I want to say -1 if the code is not good.
So how do you want to execute the test? Where?
On some servers that I run.
So the server, the actual test is executed outside of LF.
Yes.
But it is run by the Jenkins machinery in LF, so it is per patch. Well, I guess
it's possible. Sure, why not? If you have a slave Jenkins that is running in your infrastructure, and you create a new job which will verify the specific function, and it will use your hardware which is not available in the LF infrastructure, everything is doable.
So technically doable, but I think we would need to engage with LF to verify the options. I know that there is already a precedence that they have. We haven't done it.
So OPNFV is doing that. So that's a distributed CI.
Yep.
So basically, you push.
Oh yeah, they are using interlapse and at least
yes, you have pods and you have machines. People don't have access, but they publish the results. So you feed with binary, and they feed you back with test results.
So that would be an excellent maybe a discussion point or engagement that we would like to have, because so far we've been concentrating on bringing up the stuff that we already have in LF, and we want to enable some of the labs in Cisco for sure. But hardware-wise, I mean, there's going to be a quite VPP. The guys are adding more code faster than we can test. So and also so far the physical testbed in the lab has been quite static. So we have, I think, total of three nodes testbeds, so 9 machines, and so far we haven't seen anything else being contributed. So happy to discuss it further, Vincent.
What's the question? Well, the performance testing is exactly the same as a functional, but we are not sending 1 packet, but we are sending 10 Mbps. And we are measuring how many packets have been lost currently. Throughput. There is a binary search that we are using starting at the top, and if there is a loss, then we go to the half of the interval, and we basically find where is the non-drop rate throughput. And last week, from what I remember, we added the 0.5 PDR. So we are measuring not only the NDR rate throughput, but also the partial drop rate at 0.5% loss. And currently, A colleague of mine is working on adding the latency measurements as an addition to the throughput. Yeah, well, there are good question. Thank you. Currently, there are two types of tests. One is the long, and then second type is the short. The long test is using the binary search to find where the NDR rate is, and then the short test only start the traffic, measure how many packets has been lost. If there has been any loss, then it just fail the test. So that's the short test that is running 30 seconds, what I remember in total. So sending packets 10 seconds, then just take a look. If there was any loss, then just shout that the test failed.
Maciek mentioned you are using T-Rex for performance testing, and if you take Xia, then you'll find a nice RFC 2544 use case there. You can just click, select all your parameters, and you are done. In your case with T-Rex, is it something similar which is built in, or have you need to implement all this logic with RFC 2544 testing, going up, going down, looking at PDR or NDR on your own?
You just started at the top, and then you start the search.
Okay, so there's no built-in functionality in T-Rex. It's just your script doing this.
Honestly, I don't know. I would need to take a look on the documentation. But for us, it is much better to use our own library, because then we can just switch the traffic generator to something else, like Mugen or PacketGen from the DPDK or whatever else, and use the same methodology that we are using right now, and don't rely on something implemented somewhere.
The idea is to use different types of traffic generators, right? So we have already in a pipeline adding a driver for Xia, and as I said, we're looking for volunteers to help us to support other traffic generators. Also, one of the reasons why we didn't use just out-of-the-box APIs for binary search, we have a mixed experience of testing in the past, of not necessarily VPP, but other networking gear. And binary search on one tester is not equal to the binary search on another tester. And they all say RFC 2544, but there's an interpretation problem there and lost in translation. So preference is to actually know exactly what we're doing and using as simple functionality as possible. Make sense?
In case of no other questions, back to the code. Yeah, sure. So the RobotFramework contains which libraries to use. These are the resources files. Then suite setup. So we just run the keywords. Keyword is something like function. So you just execute it, and it contains another keywords or just some steps that it will do for you. It can be another RobotFramework keyword, or it can be a function written in a Python library. During the test setup, we clear for each test case, we clear the interfaces. You saw that in the browser. And then at the end, we show packet trace on all the UTs. Documentation, it should be better. Oh, here it is. So this is multiple lines describing what is this test suite doing. The keywords section contains suite-specific keywords. So for instance, this keyword setup nodes for max swap testing contains following keywords. So it is basically what I showed in the report. So we pick two nodes, compute path, then set up variables, then bring up the interfaces on both TG and the UT, wait for the interfaces to be up. And then this is another keyword doing the verification of the max swap, setting variables, generating the script gen arguments, and then executing the max swap check.py script on the TG node with the arguments that we construct in a previous step. The list of test cases is currently, in this example, is just a single test case containing following tags. So you can put their tags which you want. You can then use that for executing, like include all the test cases with 3 nodes topology, or exclude all the nested virtualization, or mark the expected failures. Enable, disable, this is a function from the library. So if you have something like this, maxswap class containing 2 static methods, and this is enable, disable, maxswap what exec, translates to enable, there is no underscore but a space between the words, but it's basically enable, disable, maxswap what exec. Keyword is what you see in the library section as this Python function. So we execute a maxswap exec what BP API test file with replaced interface name. So this is the configuration, and there should be a template of what I show you how the BP API test looks like. So this is just the exec sample maxswap and the if name. So this will replace the if name with the interface that we compute in the steps before, the previous steps, and then send and verify maxswap on node. That's the keyword defined locally, which is this one, and that executes this maxswap check pi, and that is a script located in traffic scripts doing check swap. I will skip to the main function. So it will parse the arguments passed from the RobotFramework to the TG node. Then by using Scapy, craft the packet to send. So this is some IP protocol 61 packet with source destination and IP address and MAC address defined in the RobotFramework, passed over the arguments to the traffic generators. Then I create a list of send packets because we are using the same interface for sending and receiving. So we need to ignore the packets that we send over the same interface and not count them. And then we receive a packet. So first we send it and receive, and then we check the sent and received packet in this function, which is doing basically showing the content of the packet. So packet sent and packet received, that's the Ethernet Scapy packet. So you can work that as a standard Scapy behavior. And then we compare the destination with the source and source with destination, and if that is not what we expected, then we raise an exception, and this text will flow up to from the traffic generator to the traffic execution. And if you would run it on the Jenkins, then you will see that that this is the cause why it has failed.